Welcome to the section on the ambiguous case for the law of sines. And a long explanation here. When given two sides and an angle opposite to one of these, as you can see in these drawings up here, for example, in the second one here, that's the one I actually want to use right now, we have a side B given and a side A given, and we have the angle capital A given. An ambiguous case can occur, and there may be two triangles fulfilling the given numbers. And as you can see here, when I go down here from A, it can hit the baseline right here, or it can hit it over here. Both triangles are permitted. And that happens because the angle theta, when we take the inverse sine, going through the sine of through the law of sines, that angle theta will be the reference angle in quadrant 1, but of course it exists also as a positive number in quadrant 2. And as I said, we'll come across it in example B. Also, if a side simply doesn't reach the baseline of a triangle, no solution exists, and we will find, going through the motions in the law of sines, that all of a sudden we come up with inverse sine is greater than 1, which of course is not possible. And exactly one solution is determined for several cases. For example, when the reference angle in quadrant 1 is a solution, but then its counterpart in quadrant 2 produces a triangle with the sum of the angles of larger than 180 degrees. For example, we might have given an angle A of 58 degrees. We come up with an angle B of 143 degrees. All of a sudden we're above 180 already for two angles, and so that's not possible. That will appear, I believe, in the problem section. Okay, let's go ahead here. Here we again have the law of sines written out, our typical triangle ABC, and we're having some examples, the same ones that I just showed a moment ago. So I'm going to go down to them. And I'm already pasting something in here. The numbers are not correct here, but we're going to go through the motions. So we have an angle A given of 30 degrees, B equals 6, and A equals 2. So we use sine A over A equals sine B over B. I'm going to plug these numbers in. That's what I meant a moment ago, that I have to see which numbers I need here. So A equals 30 degrees, A equals 2, sine B divided by 6. There we go. We do one algebra step of sine B equals 6 times sine 30 divided by 2. That, of course, will come up with 6 over 2 is 3 times sine of 30 degrees is 1/2. And then, of course, is 1.5. And as we're taking the inverse sine of 1.5, we of course know that's not possible, it's undefined, so therefore no solution exists because, or that is actually the reasoning behind it, that the side A is less than the height of the triangle, and therefore doesn't reach the baseline, and our inverse sine of 1.5 tells us exactly that it's not possible. We come up with an impossible triangle. And what I just did here was example A. Let's go to example B. And again, I'm just going to paste something in here, and I believe I'm going to take these down here with me. Hold on, just one moment. I'll put it right there. Okay. So for the next one, we have available A equals 40 degrees, B equals 62, oops, actually A equals 54, sine B is not given, B equals 62. We do the algebra on these. Just one moment. So because we do the algebra on these, 62 sine 40 degrees, and then we divide by 54, and we'll see what we come up with. I'm going to do this on the side. I trust that you don't need the online graphing calculator to figure this out. And on the side, all I have to do is check that I'm in the degree mode. So let's see, 62 times sine of 40 degrees divided by 54, and I come up with 0.738. 0.738. Then B, of course, in this case it is possible. So 0.738 equals, so inverse sine of that comes out to 47.6 degrees, which of course is in quadrant 1 and is also the reference angle. I'm going to plug this one in here. I guess I could have this in blue if I really want to. Okay. So we have an angle B here of 47.6 degrees in quadrant 1. But when we take the inverse sine of 0.738, we come up with reference angle in quadrant 1. But it's also possible to come up with an angle in quadrant 2, which of course is 180 minus 47.6 degrees. So I'm going to write this also, B equals 180 minus 47.6, and I believe, we're in two significant figures, so I might as well round this to 48 degrees. So minus 48 degrees equals 132 degrees, so that should also be possible. That's what you see in the second drawing here, where we have an angle right here of perhaps 48 degrees, and then we have an angle over here of, let's see, actually the angle is over here. Here we have an angle of 48 degrees, and here we have an angle of 132 degrees. Both are possible. Just one little thing that I have to check, and that is that the two angles that we have right now, 132 and 40 here, do not exceed 180, because then again it would be an impossible triangle. And they don't. It's 172 degrees, which means the angle C up here needs to be 8 degrees. So my drawing is not quite to scale, as you can see. Okay, so we have here two solutions, because A is less than 90 degrees, and A is less than the height, greater than the height, and less than B, side B. Okay. And the third example that I want to do, let's see what I'm going to come up with. Again, I'm going to copy this here to make life easy on me, that I don't have to re-type all these equations here. So let's see, in this case, of course, it's going to be sine A over A equals sine C over C. Okay. A is actually the angle we have to figure out. Oops. Side A is 205. C is given as 35.4. And C is 314. So the algebra is going to come out to sine A equals 205 times sine of 35.4 divided by 314, and we'll see what we come up with. 205 times sine of 35.4 divided by 314.378. Okay. 0.378, taking the inverse sine of that. This one will be angle A. I'm going to take this one off here. Let's see, sine of that number, inverse sine of that number comes out to 22.2 degrees. This time around, currently we have three significant figures. A can also occur in quadrant 2. I should have written that on the previous problem. It's quadrant 2 as well. Let's see if I can still have to space it. Yep, it's right there. So quadrant 2 was in the previous problem. So in quadrant 2, we come up with 180 minus 22.2 degrees equals 157.8 degrees. So there's a second possibility. However, this time around, look at these numbers here. Angle A is 157.8 degrees. Angle C is 35.4 degrees. These two angles alone are going to give us already over 190 degrees for this triangle, which of course is impossible. A triangle has to have 180 degrees total on its angles. So that second one is just going to be an impossible triangle as well. So this one here, but yields a triangle with 35.4 plus 157.8, already greater than 180 degrees, which is an impossible triangle. Thus, only A equals 22.2 degrees is a solution, and that's the last thing here. One solution in this case, because the side C actually turned out to be larger than the side A, unlike the last example where it was the other way around. The side A was larger than C. Okay, with that one, I'm going to wrap up this ambiguous case, and I have just a small number of problems left.